Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Welcome to our today's chemistry online class of Cosmic School. Today I will discuss about a very important part of chapter 4, that means periodic table. This is very important for your SSC exam paper. Without these topics, CQ from this chapter cannot be made. That's why you have to be very careful and observe the whole class very carefully. This is about periodic property. Periodic property of elements in the periodic table. The elements in the periodic table have some properties which change periodically, which change from left to right. If we go from left to right in a periodic table in a period, then these properties show some periodic trends. They changes gradually from left to right and also up to bottom, and these properties are called periodic properties of the elements. And these properties are, at first, atomic size or radius. We know atoms are too small and their circular shape, and we measure the size by calculating, by determining the radius. And second, the very important property, ionization energy, and the third one is electron affinity, and then electronegativity, and the metallic and non-metallic properties of elements. These all properties show a periodic trend in periodic table. Let's start with atomic radius or atomic size. What is atomic radius? The distance, simply we can define atomic radius as the distance. This is the nucleus and this is the shell, and for this we can this is the hydrogen atom. We can assume it's hydrogen atom. This is the first shell and this is the outermost shell. The distance between the center of the nucleus and the outermost shell, that means last shell, is called atomic radius. Atomic radius. This is for a single atom, and we know some atoms exist in nature as diatom molecules, non-metals, gaseous elements, and for that the atomic radius will be, this is the molecule, they form molecule like that, shape is not proper, they are connected by bonding, and then the center of the nucleus, then we have to calculate one nucleus to another nucleus, distance between these two nucleus, and after that we have to divide it by 2. Then we get the atomic radius, that means this portion. This is called atomic radius, and I think it is clear to you. And this atomic size or radius shows periodic trend in periodic table. If in a period on moving from left to right, the atomic size or atomic radius decreases. Atomic radius decreases. And in a group, if we proceed from up to bottom or top to bottom, then atomic radius or atomic size increases. It is clear? Yes. If we in a period in a same period, when we proceed from left to right, then the atomic size decreases, and if we go from up to bottom in a periodic table, then the atomic radius or atomic size increases. Why? Let's discuss the reason. Okay, and for example, at first we consider group 1 elements, and the group 1 elements: lithium, sodium, potassium, rubidium, cesium. The first 5 members. And group period 3 consider period 3: sodium, magnesium, then aluminium, silicon, phosphorus, then sulfur, chlorine, and argon. Then we can say the atomic radius increases from lithium to cesium. The atomic radius will be least for lithium and highest for cesium. And in a period, if we proceed from left to right, the sodium have the highest atomic radius, and argon have the least atomic radius. And now why? As we know, in a group, for every successive period, a new shell is added. What we know about the significance of period? Period number tells us the shell number. That's why this is the period 2. Lithium has 2 shells. Sodium sodium is in period 3. That's why the outermost shell is, the total shell is in sodium atom is 3. In potassium 4, rubidium 5, cesium 6. That means in every successive period a new shell is added to the atom, and that's why the size also increases. Draw electronic structure diagram. Okay, then it is clear to you. This is the second shell. Lithium has 2, and this is third. For sodium, 1, 2, 3 shell. For potassium, 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3. This is 3. This is 4. This is 2. Okay. That's why we can easily understand that the atomic radius increases. The distance between the center of the nucleus and the outermost shell increases gradually. And that's why in that case also proton number also increases. The proton number of lithium is 3, sodium 11, potassium 19, but this increasing potassium effect of increasing proton number overweighs the increasing shell number. That's why the shell number, by increasing shell number, they increases their atomic size. And now if we go from left to right, what happens? Look at this. We know this is, let's erase this. This is magnesium. Now we have to proceed from left to right. We know for this element, all these elements, the period is 3. That means the outermost shell is 3. The total shell number is 3. That means their number of shell remains unchanged from left to right. But if we go from left to right, each element has one more electron than the last one. Sodium atomic number is 11, magnesium is 12. Add 1 proton. And aluminium 13p plus proton. For silicon 14p plus. For phosphorus 15p plus. Sulfur 16p plus. And so on. 17 for argon, 18 in their nucleus. That means when we go from left to right in a same period, then their same outermost layer, their same outermost orbit, one more electron has added to their nucleus. And that's why the charge in nucleus, and as the proton number is increased, the electron number also increased. This sodium has 11 proton, that means it has 11 electron in the outermost shell, and 12 proton, and magnesium has 12 electron in their shells, and magnesium have one more electron in their outermost shell. Sodium has 1 electron in their outermost shell, magnesium has 2 electron in their outermost shell, and aluminium has 3. Let's draw a picture. It will be more clear. Okay, for sodium we draw only outermost shell. Okay, 1. This is 2. This is 3. For silicon, this is outermost shell contain 4 electron. For phosphorus, outermost shell contains 5 electron, and thus so on. Sulfur has 6 electron. Chlorine has 7 electron in their outermost shell. Argon has 8 electrons. And that's why, since the number of proton increases, that means nuclear charge in nucleus increases, and the attraction force between the center of nucleus and the outermost shell electrons increases. The attraction force increases, and this increased attraction force pulls the outermost shell towards nucleus and reduces their and decreases their size. Is it clear? As the atomic number increases, moving from left to right, that's why nuclear charge increases, and the number of electron in outermost shell also increases, and electron have negative charge, value of negative charge increases, the value of nuclear charge increases, and this increased charge feel more force between them, towards them, and that's why the nucleus attracts the outermost shell more in this element than this one, this element than this one, this element than this one. That's why the size of the atoms reduces. And that's why we can easily say when in a period we move from left to right, the atomic size or atomic radius decreases. Is it clear, student? I think it's clear. Next, we go for ionization energy. What is ionization energy? The ionization energy of an element is the energy which is required to transform an atom of any element into an positive ion in their gaseous state by removing one electron from their outermost shell. The required amount of energy, that means for this, by removing one electron from any neutral atom in their gaseous state, we have to apply energy, and this amount of energy is called ionization energy. Let's example, this is the atomic structure of lithium. Lithium has one electron in their outermost shell. If this electron removes, and for that we have to apply a certain amount of energy, add certain amount of energy, and after removing one electron we get a positive ion with a single positive charge, and this amount of energy is called ionization energy. And we can in reaction form, if this is a atom of element, and we add energy, then lithium plus ion is formed and one electron is removed from it. That's right, this is the lithium. And this here you must have to mention the state of this element's atom, gaseous state. Of course we need gaseous atom because we need isolated atom. There they have to free from another atom, but in solid state or liquid state atoms are close together, come together, but we need isolated atom. That's why this process, this calculation must need the gaseous state. Then this ionization energy, we know about this ionization energy. For removing electron we need energy, we have to apply energy. Okay, then this is also, we know this is a periodic property of any element, and how it changes from left to right in a period and up to bottom in a group. As we move from left to right in a periodic table, the ionization energy increases. And if we go downward from top to bottom, then the ionization energy decreases. How come? Why? We know already about that. If we move from left to right, atomic size decreases, and that's why atomic size, as the atomic size decreases, that's why ionization energy increases. But how? That's why we have to draw a picture. Okay, then for lithium, okay, and here we know size is compressed, okay, because charge, electron number increases, and positive charge also, nuclear charge also increases. The attraction force is increased. Attraction force is more than this one, and that's why we can say easily the outermost electrons are tightly held to tightly held to the nucleus in this atom. This is lithium, this is beryllium. Okay, that means since the size of beryllium is smaller than lithium, that's why the last electrons, the attraction between positive charge of nucleus, the nuclear charge, and the outermost electron is more, and the outermost electrons are tightly held by this nucleus, and we need more electron. That's why we need more electron to remove this. We need to apply more electron to remove this electron than this electron. And that's why the ionization energy of lithium will be least and the beryllium will be more than lithium. And as we go, if we go from left to right, then the ionization energy increased one by one. Okay, when we go from up to bottom, then the the ionization energy decreases. Why? We know the atomic size, as we go from the up to bottom, a new shell is added for every successive period, and that's why the atomic radius increases. And if the atomic radius increases, the distance between the outermost electron level and the nucleus increases. That's why the attraction force decreases. And if the attraction force between the outermost electron decreases, then it will be easier to remove this electron from it and form positive ion. Is it clear, student? I think, because I will show some diagram. Let's think this is lithium. We draw only outermost layer, and then this the size of sodium, this the size of potassium, and then the central and these outermost electrons distance is increases in successive period, and then the attraction between them also decreases. The attraction between them decreases, then the distance increases and the attraction decreases, and that's why this electron, for the removal of this electron, needs less energy than this one, and the needed energy, the required energy to remove this electron is less than this one, because they are tightly held by nucleus. So we can say, if we go from up to bottom, then the ionization energy decreases. That's all about ionization energy. That's all for today's class. Assalamu alaikum, student.